So good. Welcome to Soundstack Online 2021. I guess I'll say similar things to the things I was saying this morning, which was that, I feel like practitioners have had a really tough time in the past year, despite, being familiar with not having a huge amount of funding. I think funding to the arts is often the first thing that gets cut. So practitioners have been working with that. We've been working with increased workloads. And obviously, it's not just artists and creative practitioners that have come up against that. I think a lot of people have been dealing with that in the past year. So, and it looks like things are set to continue in that way indefinitely. And so I felt that the original ethos of Soundstack, which was always about making spatial technologies really accessible to artists and practitioners, to encourage plurality and encourage people to uptake what might seem like prohibitively complicated technologies. I feel like that's even more important now that, we're working in more challenging times. I'm really grateful that this year's event can be online because it can reach around the world. I've got amazing people on this afternoon session that I wouldn't be able to get them to come to London. And also, people can attend and they don't have the same practical limitations on actually having to move to a different city. So that's wonderful. I do just want to start by thanking the people that make this possible. So I want to thank the Media and Arts Technology Programme at Queen Mary University of London. Like many organizations, they are having to tighten up their finances post-pandemic, or we can't say post yet because we're still in it. But yeah, organizations are struggling, understandably. So thank you, Nick Bryan-Kins, Jonathan Winfield, and all of my colleagues and peers on the Media and Arts Technology Programme for your support for making Soundstack possible for the 4th year. And that humble brag segues neatly into this afternoon's session, which is about spatial sound. So this special session came really out of my own journey from trying to get spatial sound working through the browser. And in order to, the reason that I did that was in order to repurpose an existing work for online exhibition. And that proved to be really steep learning curve for me and for the technologists involved in that process. And I was thinking about my own process and thinking that it's already, I feel like it's technically impressive when you're working with spatial sound as an artist. And then we're now having to embrace an entirely, seems to be more complicated ecosystem of technologies in order to make the work online. So I thought it was important to tackle this additional complicated browser-based spatial sound experience. I would say that many practitioners have, not just in the last year, but before that, played back or streamed binaural sound online to reproduce spatial sound works. And that's, one form of representation. But for me, it creates a very static experience and it doesn't make uses of the affordances of the current technologies. So I'm always curious to find out but what can be done, rather than what's the kind of quickest or least troubling solution. Actually, we've got these technologies. They're wonderful technologies in some instances. So what can we do with them? And at that point, I started to try and figure out what this ecosystem looked like, what technologies were available. But it was really unclear to me. That's what I would say. And so this session, I would hope at least introduces everybody to some really cool tools. It gives a sense of the different type of spatial sound that's possible to work with in an online environment. I would say this is a starting point and it's not a comprehensive survey of the field, but the more that practitioners that enter the field, I think the better the tools are likely to get and the better the work is likely to get. So hence the impetus for this afternoon session, which has proven to be popular. So it must be that I'm onto a thing. So good. Our first part of the session is introducing you to people that have worked in practical projects with some tools. So we've got, first off, Tommie Introna. And then we'll go into Cobi Van Tonder, and then we will take questions at the end of that, end of the first part of this afternoon session, just in order to sort of let people speak, and maybe we can have Q&A after Tommie if Cobi has something to set up. Otherwise, we can do it towards the end. So Tommie Introna collaborates with artists working predominantly with sound and programming. He's a member of Black Shuck I hope I'm saying that correctly, a cooperative that produces moving image, audio, and digital projects. He also works with young people, facilitating peer-led artistic projects. And he's worked, the reason that I came across Tommie's work was that he worked with Call and Response Gallery based in London on their Assembly 2020 project, which was a wonderful project. Encouraging artists into this space, having them, have artistic residencies where they created works for online reproduction. I don't know that the original sort of intention was to have it online or not, but in any case, that's how it evolved. So I'll hand over to Tommie. Thank you.
Thanks, Angela. Hello, everyone. Out into the void, but it's great to hear that there's so many people attending, and I think it's really interesting to be kind of hearing about all of this now, kind of like taking stock of what's happened, what we've learned over the last year, and kind of seeing what we can do with it creatively going forward. And I'm sure I'll learn a lot from everyone who's speaking this afternoon. So yeah, Angela's just done a great introduction, but just to say, so yeah, my background is in art practice, but over the last sort of 5 or 6 years, I've been working with young people in art programs, but also doing sort of side by side that various kind of collaborative works with artists, musicians, and galleries, producing kind of all sorts of works that kind of use technology, where someone wants to use a piece of technology and not quite sure how to do it. That's usually where I sort of start getting involved in a project. And most of my work is done through this cooperative called Black Shark. And I'll drop some links into the chat after this is finished, so you can look us up and get in touch if you're interested in the kind of stuff we're interested in. So the project I'm talking about today took place last year. We were approached. This is the kind of site, and I'll just post. Where's Zoom? I'll just post the link into the chat if anyone wants to look it up. This was a project that we were approached by Somerset House Studios and Call and Response, who were doing this, where they wanted to do a residency where they would invite artists who worked across visual arts and sound to produce new spatial audio works. We're working with Call and Response, amazing studio in Somerset House, to kind of explore that potential for people who haven't really worked in spatial audio before. And it was originally supposed to be an event, I believe, and then obviously, with the pandemic, it became an online project, and that's where I became involved in the project. But maybe before I start talking about the project in depth, my background is I've worked in sound, I've worked in programming to a degree, but I'm not an expert coder, I think. And I sort of definitely not an expert in spatial audio or spatial audio in the browser. So I kind of say this maybe to hopefully inspire some confidence in some of the artists who are in the audience that as kind of daunting as some of this stuff might appear at first, it is, you can get your head around it and use it and potentially use it in interesting ways. So basically, if I can do it, then you guys can do it as well. Somerset House Studios, they wanted this platform. They wanted it to have a very bespoke feeling. They wanted it to not be another YouTube live stream kind of experience. They wanted something more where the kind of artworks are more integrated into an environment that they could carefully design and curate. And that was kind of the kind of crux of the brief for us, to try and figure out how to get spatial audio into this site in a way that kind of felt nicely integrated. If you go to the site, it might be confusing when you first get here, but if you click on archive at the top, you get those 5 artists. And if you click on those, you enter the listening space. So the first space is a kind of a lobby area, and then once you go inside, you can listen to the music. I'm not going to stream the sound right now because Zoom will probably destroy it. But this is the kind of audio space, listening space, and the design for it in the end actually was extremely simple. And you'll see when I talk through the implementation that we actually implemented the spatial audio in quite a simple way. But effectively, the listener can look around this sort of dreamy space and listen to the sounds that the artists made. So our first kind of thinking was, and perhaps the most obvious kind of first point for a lot of us when we think about spatial audio online is to kind of think about it embedded in a video, in a 360 video, such as Facebook or YouTube. And I think because of this, because of their desire for it to feel kind of quite bespoke, we weren't super keen to use one of those platforms because it had some limitations in like the quality of the spatial audio resolution. The YouTube can only do first order ambisonics, and there was also kind of like, I think they wanted it to feel very self-contained rather than something that kind of like would feel like a YouTube video. So there was kind of like some ideas there. But I think like for us as programmers, we were quite interested to kind of push it a little bit further and see what else we could do. We were kind of curious about the other options available. So for us, it would have been a bit boring to make a YouTube channel, a YouTube 360 video. So we were pushed for something a bit more ambitious, which is when Tom, who works at Call and Response, mentioned Omnitone, which he had heard of before, but I don't think he had used it. And we actually ended up using Omnitone for this project. So I'm just going to, hopefully you can all see that okay. I'm just on the GitHub of Omnitone. I'm just going to like run through and maybe hopefully demystify a little bit what's going on this GitHub, that sort of overview of what Omnitone is capable of. As you can see, it's a project of Google Chrome. It kind of was released. It was very active about 3 or 4 years ago, but it hasn't been very active since then in terms of updates. But it still works fine, and it's still implemented in some of Google's other kind of products. So what is Omnitone? Omnitone is a robust implementation of ambisonic decoding and binaural rendering written in Web Audio API. So there's going to be a fair few people this afternoon talking about Web Audio API and in more detail. But for now, just to understand that Web Audio API is a way of working with audio in the browser that is a lot deeper than just sort of simply playing audio files. You can do a lot of fun things with Web Audio API. And this is what Omnitone is built on top of. So Omnitone is a sort of way for us to interact with the Web Audio API in a very, they kind of take care of a lot of the harder aspects for us. One of the cool things about Omnitone is that it can handle higher order, up to third order ambisonic files. So as I was saying before, that gives you sort of more of a realistic, higher resolution, if you like, experience of spatial audio, which which is a big draw of it. I'll really quickly go through this diagram because I think it is helpful, just to like give you a sense that like what all of this is kind of saying, and maybe what it is capable of. So Omnitone, there's like different ways of doing spatial audio in the browser. What Omnitone does is it streams an ambisonic sound file. So this is like a linear sound file, multi-channel, that can be decoded to a binaural kind of experience. There are probably there's lots of other kind of interesting like non-linear ways of working with sound in a spatialized way in the browser, but that's not what Omnitone does. Omnitone plays back an audio, an ambisonic audio file. It can use 2 different ways to feed that audio into it. one of the ways is they're using the HTML media element, which is what we use. And this was really key for us because some of the files that we were playing back were over half an hour long. So the streaming the audio in using like the audio buffer or something like that was not efficient enough. So this was a really handy, simple way to feed audio into Omnitone. Omnitone then it feeds those multi-channel audio into its renderer. That's the higher order renderer or the first order renderer. That's what FOA and HOA stands for. The renderer has two main aspects: the rotator, which is positioning of the head or the camera, if you like, and the convolver. I always struggle to say that, but the convolver is taking care of processing this multi-channel and decoding it to a two-channel headphone binaural experience. The rotator is telling it exactly how to do that based on the rotation of the head. So I won't go into more detail than that because I'll run out of my knowledge will run out of steam, and you all probably know a lot more about these kind of things than I do. But it's sort of, that's what's going on inside the renderer. And then you'll see there's also this rotation matrix. So this is an external input, which allows us to link the rotator to another rotational matrix from, say, a camera in WebGL or 3JS, which is what we ended up doing. And I'll kind of come back to that in a second. This is actually, and I'll really quickly run through this because this is actually how it is implemented. So yeah, like I said, it's using JavaScript, so it's not the most intimidating kind of thing to work with. We're setting up a HTML audio element that's going to play a WAV. We're setting up an audio context, which is a web audio API thing, but where audio context is kind of like, it's the context of audio in our browser. We are letting it know that the source for the audio context is going to be our element. We're creating a renderer on the first order in this example. And then we're initializing it. So the first order renderer is initialized. Once it's initialized, then it connects the audio element source to the renderer's input, connects the renderer's output to the audio destination. We click play, it starts the audio. So it can be a very, very simple implementation. And then once we've got it hooked up, we need to let it know the rotation, which is where this comes in. And high order it's very similar with high order. It's not a significantly more complicated setup. So with the rotation, the way we set it up, so if I show you the site, you can see there's like basically a three-dimensional world, and that is built on 3JS, which is a library for working with WebGL, so rendering three-dimensional space in the audio in the browser. And we actually used exactly this example. We stole the kind of camera movement from this for our thing. So if you imagine the camera as I'm spinning this around, the camera is rotating, and that rotation is documented in like a matrix of numbers. And in Omnitone, we're literally linking the camera's matrix world.elements, which is this matrix of numbers that's telling us how the camera is orientated. And we're linking that to the renderer's rotation matrix. And it's really that simple to kind of connect 3JS and Omnitone. And once you've kind of set this up in the animation loop of 3JS, it's basically continually updating that rotational position. Sorry if I'm speeding ahead, but I'm kind of just wanting to show you kind of, give it a go, because it is a relatively accessible way to do this. So my overall experience of Omnitone was good. There was not a lot of continuing support. If you look at the issues, there's not much activity for the last couple of years. So there was some kind of Googling and some issues that I ran into, but on the whole, I found it quite easy. Our biggest issues that we ran into, and this will be common across many of the people, and you'll all have come into these kind of issues before, is one, the format of the audio. So obviously streaming, how many channels? 16 channels of WAV, like wave files that are like 45 minutes long, is going to be kind of insane file sizes. So that was kind of immediately something to kind of think about. We opted to use predominantly the Vorbis OGG format, which is a lightweight, high quality format that's common across the web. However, it's got one major issue, is that it actually doesn't work on Safari, iOS, or Safari. We started a long rabbit hole trying to figure out what's the best way to get around that, so we don't have to stream WAVs to Safari users. We looked into ACC, which is a commonly used codec with video codecs, but we couldn't, and maybe someone in the audience or on the panels knows how to do this, but to convert the WAVs into multi-channel ACC, I think it's ACC, not AAC. I might be wrong there. But to convert those into multi-channel ACCs, we kept running into issues where it would render it with like 7.1, the low frequency channel would be filtered out. It was causing a lot of headaches. So in the end, we had to compromise because we were running out of time, and we set it up so that Safari users would stream WAVs at first order, so only 4 channels. And it was still very heavyweight files, but in terms of the streaming, it didn't have a major issue because of using that HTML audio tag. But it was obviously, it's not ideal asking someone to download 500 megabytes sort of files, etc. The second kind of major issue that kept coming up was more actually to do with Three.js and the rendering of WebGL in different browsers. If you run it in, like right now in Chrome, it seems to be running nicely, but in my laptop's on Chrome, it doesn't run nicely, and I think that's something to do with the graphics card on my laptop, which is very old. But then Tom at Call and Response had a graphics card that was extremely new and very powerful, and he was having issues. So compared to like using it in a video, say, we're just with web things, you do just run into lots of like difficulties. And usually the solution is just run it in Firefox or just try a different browser, but you don't always necessarily want to tell your users that. It kind of sets up a barrier that you don't necessarily want. But we did, like, mostly, I don't think we had that many reports of issues, and it's sort of, I guess people are quite used to having an issue and then changing browser, so it wasn't the end of the world. And then, those were our sort of our biggest things, but maybe we can talk more about extra in the Q&A. But just to summarize, like, I think this is for us, it was a very interesting thing to try out. I feel like there was a lot more potential in terms of like creatively working with spatial audio in the browser beyond just simply playing back an Ambisonics file. But even in that, I think there could have been more to explore, because we're working in the browser. There's the opportunity for user interaction, which we didn't really do anything with. There's potential for to be drawing data from elsewhere or anything else that could be influencing the sound. There's potential in Web Audio API for processing sound and doing creative things like that's being rendered in the user's browser. So I think there's a lot there's definitely a lot more potential within it. But if you're interested to, if you've produced a Ambisonics a piece that is an Ambisonic rendered as an Ambisonic file, or you're trying to translate like something like that, that's quite a static thing into a to be presented online, and you don't want to use it in a video because, say, you want to create an environment that is doing something else that's more evolving and more, you can integrate it into your website a little bit neater. Omnitone is really, really good for that. And yeah, my overall experience was that there was a lot more headaches on the sort of front end visual side of things than the sound side of things. So yeah, I think that's all I'm going to say for now, and then we can probably pick up. I'm sorry I rushed ahead and I didn't like if there was any terminology or if anything that wasn't clear, just let us know in the Q&A and I'll get back to that.
Thanks, Tommie. No, I think it was really well explained, and I'm always a fan of people finishing early rather than late, so thank you. I guess it makes me really, I kind of remember why I asked you and Cobi to be first up is actually we've got probably, if regular Soundstack is anything to go by, we've probably got a real mix of people attending, people that are very, technically capable and, have made these kinds of tools for others to use, and people that this is the first they're hearing about any of this. So it's quite a mixed audience to speak to. But what I'd say is that Soundstack's focus is really about exactly where you're pitching it. It's like demystifying it so that people don't feel so intimidated. So thank you. And I definitely have some questions for you, but I'll give you a little bit of a break. Nothing's come up in the Q&A. So we'll head over to Cobi now. And as Cobi fires up, I will do the obligatories with the bio. So Dr. Cobi Van Tonder is a creator, composer, and Marie S. Curie Research Fellow at the University of York. Acoustic Atlas is a browser-based platform for virtual acoustic simulations of natural and cultural heritage sites. Many heritage sites are documented in great detail from a visual perspective, but sonically there exists little data. Acoustic Atlas is a collaborative archive in progress for acousticians, archaeologists, and sound artists to share sound data as immersive real-time oralizations. I feel like that's super clear. Thank you, Cobi, over to you.
Let me just see here. Hello, everyone, and thank you so much for inviting me. I'm just hoping you can see my screen. Sorry, I lost the Zoom window.
Yep, we can see it.
All right. Okay, for some reason I can't see myself anymore, but that's fine. So I'll just go by this. Yeah, so I like to call my practice, the overarching part of my practice, expanded listening. And what I mean with that is just like listening to the world in kind of non-usual ways, not just sticking to the stereotypical concert hall format or TV format or cinema or whatever, but to really think of like being inclusive of any way that you can listen, and that includes audio physical experiences of sound through infrasound, through vibration, and in the case of this project through acoustics. So just a short, I think actually you've covered it, but I would just like to mention my supervisor, Mariana Lopez, who is working with me on this project at the University of York. And just my email address there. I would love it to get any feedback. So please do get in touch if you're interested to collaborate or to give comments or whatever. And then also just a quick thanks to Dr. Lydia Alvarez Morales for sharing her UK Cathedral acoustic measurements, Professor Gino Iannace for sharing measurements of the Witches Valley, the Cumaean Sibyl Cave, and the Year of Dionysus, which is currently being uploaded. And then also the Open Air Collection, I'm using some of Ableton's impulse response collection and some recordings by myself. And then all of this work is not mine. Someone, Carlo Catano, who is a wonderful musician and coder, helped me to implement the web audio convolution reverb using tone.js. And also Girgana Chatskova, who helped with the infrastructure and Cesium Globe. So when we think of spatial sound in the browser or otherwise, I think the first thing that comes to mind is typically panning and position of sound. Whilst that is obviously a major part of an immersive experience, I think there's another part that's often forgotten. Here's just another example of, just to make it very visible, this is the work of Bernhard Leitner, who's done a lot of, since the 70s, panning and wonderful spatial sound experiments. But when you think of a space, the acoustics is, for me, almost the most important part, especially when it comes to an empty space or an empty building. And it's just wonderful when you close your eyes and you experience the reflections, you know, and the volume, the dimensions of the space through an echo, through, you know, placing your own voice into a space. And just thinking of the form, you know, the textures of the surfaces around you, and how porous the building materials may be, and how all of these things affect the sound. And so there's a scientific acoustic technology that maybe many of you are aware of, and maybe some of you are not. So I'll just give a very quick background. I just want to see this video panel, so at least I see someone. There we go. And so basically, there's a method called acoustic fingerprinting. And basically what it does is you capture the acoustics by creating an impulse.
Can I interrupt you? Sorry, it's just now that we have those videos, they are actually obscuring the full screen of your presentation.
Oh, sorry. Sorry.
I think
I'm very bad at Zoom. Hang on. Let me just... Also, my mouse is not... Hang on, let me just get out of here. And
maybe for the presentation, we can have the view.
Oh, I need this view. Yeah. Okay, well, is that okay?
Well, the presentation's smaller. It's not full screen now, so I imagine if you can live without the video plus, that would be, I think.
Okay, it's just like talking, like the void is
void,
kind of expanded, but okay, fine. So let me see, where was I? I will just go back one and see where is my full screen. Okay. So yeah, so basically you create an impulse, like a starter pistol, or just a loud sound that activates, that gives basically a full frequency range response. A common other method is a sine sweep, playing the full audible spectrum. And then what's called the impulse response is basically the answer of that point. So there's, of course, a lot of actually a huge amount of nuances depending on where you place the microphone, where you place the source, how far they are from each other, where in the space it is. So it's kind of can be infinite because each position is slightly different. But basically, this is at the core of the acoustic atlas. The acoustic side of it is using this to through a process called convolution reverb. The left corner here at the top, you can see just a spectral image of a spectrogram of a female speech, and then in the left bottom corner you see the impulse response, and on the right you see what happens after convolution. So it basically, well, sonically it sounds like you are there in that specific position. And so, yeah, just to repeat, so the ideal situation would be to have an anechoic audio signal, and with that it means a completely dry signal that has no reverb or echoes in it, embedded in the space, and then you convolve it with the impulse response. And this process is called oralization. So, so yeah, just as a summary, what actually I think is amazing about what's happening in the browser here is that it's real time. You can, instead of listening to an example that somebody else prepared, you can put your own voice or any sound that you want to project through your microphone into the space. and therefore you can kind of be present and have a feeling of real-time exploration. So the aims of this, the overall, there's many ideas around this, and it's really in the beginning stages, is to just have a growing archive of wonderful researchers' work that that I've encountered, and that's actually inspired this project. But often I just feel really frustrated because I read about their work and I read about all these amazing spaces, but I can't listen to it. And so also with the aim to focus firstly on cultural and natural heritage sites, but obviously you can apply this technology to any other space. My choice specifically is to for the spiritual and historical values these places represent, to try and have a digital blueprint in a living, easily accessible format for people, also for artists to be able to use in say, a musical composition. And then just a quick disclaimer, I'm going to do a quick demo, but just yeah, there's a lot of things on the wish list that I still would like to do. For example, external and internal listening points. Perhaps out of this panel I will get some more leads onto how to do B format, higher order impulse responses in the browser, so that you can also add the 360 head movement. And then the website itself just needs some more other things. I won't elaborate more. So I'm going to try and start the atlas here. And if it clicks, it's probably going to be Zoom doing it and not the website. So just as a side note. Hello, I hope you can hear me. These are some UK cathedrals. And there's a setting to do a more drier signal. And then for singing in I'm also going to show you something that's quite remarkable. I can open more than one acoustic atlas. So I can, in a future version, layer it. Now we have both the Taj Mahal and the York Minster. Like this. One of the other things that would be nice would be to have a shared experience. So instead of Zoom, we could meet in here. Then I would just like to show one more thing. Well, I have two more things. First, this fantastic site by Professor Iannucci. And then a completely artistic, not real impulse response, just an experimental way of using the application. Sorry for my mouse sound. So this is a 15-second long sound file used as an impulse response. Okay. So then just a little bit about why do this, and I think, well, there's many reasons, but one of them is to cultivate the capacity to listen. And this project was kind of inspired 10 years ago, but so long before this current situation, and now it seems even more necessary. It's just to protect, to protect the listening spaces, and but also to enable people to listen and to become more aware of listening. And this is inspired by Donna Haraway, who in Art in the Anthroposphere talks about cultivating our capacity to respond. And I think a very good way to respond is through listening, because often we make so much noise and we say a picture is worth 1,000 words, but maybe that 1,000 words, if we took the time to listen to it, would have actually meant a lot. So just again, this idea of the, the immense visual data that exists. You can walk around the entire Earth with dense data, but you cannot hear it. Or there's some sound maps, but not at the same scale. So then just quickly, please tell me how I'm doing with time, because with this mode, I can't see anything on my screen.
We maybe have another 2-3 minutes. I mean, it depends on how much time we've got for questions, but yeah.
Okay, no, that's perfect. So for me, the working like this, first of all, the main obstacle I think is always latency. It's just going to be, especially if you're trying to make music, if you do slow drone music, which I happen to love, that's fine. But if you're going to do anything percussive, that's obviously always going to be complicated with online sound. And then the biggest positive was I'm shocked how easy it was to do convolution reverb, which is a very complex function. And I've tried to open 10 instances of the acoustic atlas, and it still sounds good. I don't get any clicks, so I'm quite surprised. And I have a feeling that it will function quite well since the processing happens on the client's device. So it's I need to check this, but that means the website won't crash so easily. And most importantly, it opens something that's not achievable in the real world. I did actually try this in a project where I sent sound through a speaker into a microphone to try to connect remote spaces, and it was kind of logistically very complicated. So yeah, and I will actually just end at that point. Thank you very much.
Thank you. That was great. Thank you. Okay, I have been monitoring. There's a Q&A and there's also a chat that Tommie has kindly been sort of responding to people, but there are questions that have come up, and I'm sure they will continue to come up, and I'm sure this will be the case for all of the panelists this afternoon, because we're in a fairly compressed time. So I would encourage the panelists just to monitor chat and the Q&A to answer anything that I don't get to. I'm going to go first, host's rights, just with both of you really from a practitioner perspective. I wonder, and apologies if I've missed this with you, Cobi, I'm slightly multitasking, but I know that Tommie, you implemented second order ambisonics. I forget what order of impulse responses you've used in your work, Cobi, but I wondered if you could talk me through the balance of kind of like the ideal and then the time constraints and the practical sensibilities around why you settle on the order of ambisonics that you do, because often the discussion is around, you know, very high orders when you're dealing with people theoretically, and even, you know, if people are creating static work, high order is you know, it's like a badge of honor, and I understand why, but there are practical considerations when we're working in non-linear environments. And so yeah, I just wondered, that was one of the questions that then I had, and then one was a very broad question of whether you would do anything differently if you were to do the same project again. And that goes to both of you. I don't know who wants to go first.
I think with us, well, Omnitone can reach up to third order. We actually did settle for second order, and that was, we were kind of partly just playing it safe. I think third order would have been fine. But the way the website was going live, it was kind of marketed as this kind of live moment when lots of people would be streaming from the site at the same time. And I think we were just like, yeah, I was just like, maybe let's just play it safe and do second order. And then with the WAVs, with that whole issue with the compatibility with Safari, that was first order, just to keep those file sizes within a reasonable limit. But yeah, I'm not sure in the browser if there's many services, like many tools that will allow you to go beyond third order currently. But I think that's just a limit. Again, like in like Omnitone, it's also using convolution. So which is it is a relatively intensive process. So I think it gets magnitudes more heavy duty as you go up.
Great.
Yeah, actually, sorry. Tommie, I would love to talk to you, and I'm going to check out this Omnitone to see if there's a way I could maybe put that together with convolution reverb, because I'm actually just working with stereo files, and when I do have B format, I've been converting them to stereo. So like I say, I'm kind of in the early stages. There's a year and a half left to develop this, so hopefully it will happen.
No, I can imagine that will be amazing once you can be in the space, because it's like a next level of immersion in terms of like being in the spaces that you're documenting, to be able to kind of turn your head and kind of experience the change in dynamics when you're kind of in the space.
Yes, absolutely. And also to have multiple points so that you can create a feeling of flying through or moving through a space.
That sounds amazing. It sounded incredible. Even, someone said in the chat, even over Zoom, it was sounding great.
Yeah, thank you guys. I have a question from Konstantinos for Tommie. Any chance to elaborate on the deployment? I wonder how much of a hassle it is to deploy such apps on a server. And I think that was where you made the compromise on the Ambisonic order, wasn't it, Tommie?
I mean, in terms of it was no different from sort of, for us, it was just, it was relatively straightforward. There was no real issues. I don't see why you wouldn't be able to use it. I think, were you also asking about Node.js? I can't see any issues with it running in Node.js. And in the browser, someone also sent over an example from Justin of someone running it on Glitch. It's very straightforward to run. There's no sort of major stressful hiccups with it, in my experience.
Great. I have a question, and that's been kind of answered from somebody for Cobi. Will these reverbs eventually be rolled into a plugin for use inside a DAW for composing or web audio? Very cool. But then Mark has responded to that by saying that you can use the reverbs with a few plugins already. So maybe, Cobi, you could elaborate.
Yeah, it's all dependent on time and maybe funding, but I absolutely want to actually make a globe that you can hold in your hands and play. Okay, that's now but like a controller for but a standalone thing, but of course a plugin as well that you can use in any DAW. And I think for me the beauty of this, because you can already load any impulse response into existing software. The Convolution Reverb Pro in Ableton Live is my favorite. But having this connection to the earth, I think, is really special, to not only have this abstract sample, but to really have the beauty of you're working with something real, is kind of important, I think.
Yeah, I like that, because it's like in a DAW, it's sort of disconnected from it. It becomes a tool that's sort of just like an impulse response because it sounds nice. With your platform, it's more specific to a localized place, and it sort of reinforces that.
Yeah. I mean, I really like the artistic sensibility that you bring to, this conversation, and both of you actually, but yeah, I'm really interested in seeing what applications there are for your work, Cobi, to develop it further, because I think you have plans to do that. Tommie, at the time that Assembly 2020 launched, I did get some students of mine to, in class, to have a listening session with the work. And one of the things collectively we observed was that it was quite difficult to, I mean, I don't know how much experience the artist had with working spatially, but because you were able to pan around effectively with your mouse, and then you also had moving sound sources, in the end, it was quite difficult to track things. And so I almost feel, and this is, you know, this is actually a statement that I'll make about many reproduction environments for non-expert listeners. I don't know that I'm comfortable with that term. But anyway, there we are. Is that you almost need, there almost needs to be a process of bringing people along into spatial listening specifically. And so then if there's too much going on, you know, the details will be lost. I wondered if you could, I know that you were brought in for the sort of implementation, but did you have a chance to work with artists at all to talk to them about their strategies?
Not as much as we would have liked, but I completely agree with you. I think that it's really interesting. Some of the works, I think, work more successfully in that way, where they've understood a little bit about how to take the listener, or like how to kind of help the listener understand what's happening, and and it was interesting. I think because the environments are non-visual or like static, there's very little to help you identify the sound sources. And also in music, and we're quite used to like artificial environments where we have panning that's quite extreme, or you know, like sound sources that are positioned in very like not in a sort of standard stereo spatial image, like in a traditional sense. But whereas with electronic music, we're very used to hi-hats coming out from nowhere and coming across, and that, so when I kind of felt when I was listening to some of the pieces that, yeah, because I'm so used to kind of a bit of a spatial disorientation in a lot of those kinds of music that the practitioners work in, I almost missed the actual spatialization, particularly in this platform. And I think another aspect that I found was tricky, like a bit of a limitation or tricky thing, was you kind of, you look around for a while and then you sort of stop looking around. And I think that's maybe common to a lot of like similar platforms with where you have a 360 environment, is that at first you're like, oh cool, I can look around and the sound changes a little bit, but eventually you sort of settle into a kind of position where maybe you don't actually look around that much anymore, and then it's sort of a question of then, yeah, what is the spatialization bringing to the piece, or like how is the artist using it, and like yeah, it's a sort of, I think it's a tricky question. I think Tom would be a great person to talk to about that from Call Response, because he worked much closer with them actually mixing the audio. But yeah.
Great. Thank you both. Wonderful session, and I hope you look around, and yeah, there are lots of comments and questions for you if you're willing. Okay, I'm going to move on in the interests of time to keep us on track. So the next session is about Ambisonics through the browser. We have Tommie and Nils formerly from IEM in Austria. Tommie Deppisch is a PhD student at the Applied Acoustics Division of Chalmers University of Technology, working in the realm of spatial audio. Nils Meyer-Kahlen is a PhD student at the Alto Acoustics Lab. Since his master's, his main interest has been spatial audio processing and perception. His current aim is to faithfully reproduce the acoustics of different spaces for mixed realities. So I'm going to hand straight over to these guys, and they're going to talk to you about host.
Yeah, thanks, Angela, for the introduction, and thanks for inviting us. And I will start sharing my screen because we prepared a couple of slides, and you should be able to see them now. Yeah, and like Angela said, so Nils and I both used to study in Graz and did a lot of project together with the people at IEM. And also there, the Horst 360 project actually started something like 2 years ago. And it is a 360-degree audio video player with spatial audio, which runs in the browser. And actually, what's quite nice is that you already were discussing some of the current limitations of spatial audio in the browser. And we believe that with Horst, at least some of them, we were able to solve. And with that, I give the word to Nils for a couple of minutes, and he will start explaining our initial motivation for this project.
Hi, thanks. So we thought it would be nice before we go into some details to show you how it all started, and it was actually in an artistic context and with a serious and clear problem. So I think it was about 3 years ago, Tommie and I were asked to do some 360 video and audio documentation of some installations and performances. Like this one you can see here. This is actually Winfried Ritsch's automatic piano moved through the city of Graz by Christoph Essi. And under the windshield here you can see the Eigenmic and the 360 camera. So we made this video, and then we were quite sad that at the time we didn't really have a player to look at the 360 video and then have the higher order Ambisonics to go with it. And that's how it started. So then we figured we need to make one, and then we put together Horst. So it's a browser-based open source 360 audio video player, and it has some special features. So it can go up to 4th order. At the time it was, I think, well, YouTube is still limited to 1st, and then Facebook at the time, I cannot remember if it was even there. And then it has some special things like this zoom, so you can also zoom in and out of the video, and also acoustically get a little bit the impression that you're going closer to a certain source, or kind of focusing on a certain source. Yeah, and then since recently it also works in VR headsets like the Oculus Quest, which is quite cool, and also it can receive live streams, and that's maybe one of the differences also to other solutions, that it has adaptive streaming incorporated. But Tommie will talk about more in a second. And then there's also one other thing. So Horst is just the player. You can get it from GitHub and use it locally or host it yourself. But there's also the Horst library, which is hosted by the IEM in Graz. And there you can upload your 360 productions and share them under Creative Commons license. So that's a bit like a YouTube for 360, but under different terms. And right now it's so that if you want to upload something there, then you can contact us over the contact form on the site. Okay, now for some details.
Yeah, I won't go into very much into details here because we don't have the time. But fortunately, Tommie already talked in his presentation before a bit about the web audio API, which is also what we are using, and which is probably the way you want to go if you do audio processing in the browser. So our audio processing is also done via the web audio API. We chose not to use Omnitone because it has certain limitations, which Tommie pointed out already, like the Ambisonics order is limited to 3rd order, I think. And also we wanted to implement additional processing routines like our acoustic zoom, and we implemented like a superior binaural decoding algorithm, which was developed by the people at the IEM in Graz. So that's why we decided to implement most of the stuff on our own. And on the right-hand side, you can see a little signal flow diagram. So you see on the top that we are using MPEG- audio and also video streams, by the way. So we are using an adaptive streaming technology that adapts the bitrate of the content to the bandwidth of the client. Then we're using the corresponding -JS media player and feed all the audio channels, which are up to 25 audio channels in case of 4th order Ambisonics, into the HTML audio element, which sends our audio data to the media element audio source node. And at that point, we are within the web audio API and can do our processing there. Then we implemented our own rotation and zoom routines, like I already said. And these are controlled by the field of view of the video player, which you can control with your mouse by dragging. Or if you have a VR headset, this is automatically controlled by your view and by the tracking of the VR headset. Then the signals are getting sent to the binaural decoder, which decodes everything to 2 channels, binaural audio, which is then sent to the audio destination node, which is hopefully connected to your headphones at the client's ends. Let me see if I forgot anything. Yeah, so we have 360-degree video, and like I said, we support some VR headsets. So most of them, I think, at this point, at least the biggest one. So since last week, we support also Oculus Quest and Oculus Quest 2 on their native browsers, as well as on Firefox Reality. And yeah, this we implemented by using the WebXR interface. Yeah, that was what I wanted to say about the details. We also published last year. So we published the player and the host library last year during the AES convention. And there we published an e-brief where there are further details. And if you're interested, you can read the e-brief or contact us later or ask questions, of course. So now the most interesting question actually in this setup here is what can Horst do for you? So how can you use Horst for your own projects? And like, depending on your background, there are different ways how you can use Horst. So you can, like Nils already said, you can publish your higher order Ambisonics compositions in the Horst library, which is managed by the IEM at the moment, or not at the moment, it will stay like that. And you're welcome to send us your audio and video files. And even if you have audio only compositions, you're welcome to send them to us, and we can generate an energy map kind of video to that. So we can still publish audio only content also. The second thing, how you can use Horst, the second method is you can use Host 360 locally. So you can just use our source code. The player is completely open source. You can download the source code, deploy it on your own server, or just run it locally as a demo. So you can use it offline with your projects or on your own website. And there are 2 recent projects which I want to point out very quickly. There was the Märzmusik Festival in Berlin happening just last week, where they used the Horst 360 player just for some experimental video on demand streams, together with the Fraunhofer Omnicam. So people from the Heinrich Hertz Institute in Berlin used the player. And last year we actually did the first third order Ambisonics live stream during the Audio Mostly conference in Graz, which was quite a success. And yeah, for some closing words, I want to give over to Nils again.
Yeah, thanks. So here you have some links, and on the next slide, there should be some words of thank you to many people. I was there when we were still moving the piano around in the city, but then after that, many more people have worked on this and used it for different projects. Yeah, the IEM has provided funding, and also during the Audio Mostly, Johannes Zmölnik and others have really worked a lot on this too. Yeah, and now we are really happy to take some questions, and especially it would be interesting for us to hear what kind of projects or what kind of web projects with Ambisonics you have in mind. I was already really inspired by what we heard before. Cool stuff.
Great, thank you guys. That was very informative. I haven't had any questions come up in either the Q&A or chat since you've been talking, and I wonder if anyone that is either attending as a member of the audience or on the panel, whether they've had any experience with it. I have, and I have given the right to speak as a host. I have this kind of control to a colleague and friend, Tom Deacon, who also worked with Host with me. And so perhaps we can say a little bit about it. The link's just gone up in the chat for everybody that wants to check it out. Yeah, I mean, at the point at which I was trying to get, it was a Unity cinematic VR film with interactive sound. I was trying to make that work online for Ars Electronica last year. And so that's when I was surveying and seeing, is this possible? And in my naivety, I thought, sure, yeah, you just build it for web from Unity, right? Like no problem. And then things work. Oh no, things do not work. So yeah, I think once you've built something, you know, high order Ambisonics, and you want to preserve that because that's an integral part of the work, then you start looking around trying to figure stuff out, and that's where we came from. So I wondered, Tom Deacon, if I could make you a panelist, but I can't. Other than that, I wonder if you could just ask questions, because I know that, you know, we were sort of at the sharp end of this against time pressures again. So yeah, Tom actually implemented it, but then had to travel somewhere, so it got passed back to me. I tried to do stuff with it, and then I passed it on to somebody else because I was also doing other things. And this is the reality of making stuff work, right? Like it's often not under ideal conditions. So I'm going to ask Tom, and I'm hoping that he's there.
So one thing I might add is that so if you really want to run the player locally and not just use our web service, just send us the file and let us do the work. If you want to do that yourself, then there's some kind of codec work involved. So you need to transcode all your files into Opus, which is the codec we are using, because Opus is a codec which allows you to do multi-channel audio in web browsers. In most web browsers, I have to say, not in Safari browsers. So that's why Horst, by the way, does not support Safari browsers. And this might be a bit tricky at the beginning, but we're happy to help anyone with that.
Yeah, I don't know that Tom is listening, because he's not unmuting. But I know that one of the issues that he said there was a drift in terms of the 0 point between the sound and image, so that didn't align over time. I don't know if that's an issue that you've come across before. And I don't know that I'm paraphrasing that accurately. There are a couple of questions that have now come up in the chat, so maybe we'll go to those in lieu of Tom's input. Does Host work only with native higher order ambisonic recordings, or also lower order, which is being converted up to high order?
So Horst will serve any Ambisonics file you send us, and no matter if you encode sources artificially or you record something with your microphone, and it supports not only fourth order, but first to fourth order. So any Ambisonics file you send us in between first and fourth order, no matter how you composed it or how you've gotten it, will work with it.
Yeah.
As long as it's in Ambix format.
Yeah.
Yeah, we know that. And then another question I have from Sarah: does Host integrate with Unity for building to WebGL, for example, inside a 3D environment?
So not sure how to answer this. So inside, Horst is also using FreeJS, which uses WebGL. So WebGL is used in some way, but we have this video player framework around that. So I'm not sure if I understand correctly what the idea of that would be.
I think if you haven't used it, then maybe you haven't sort of put the pieces together in your mind. And if you're working in Unity, maybe that question comes out of that rather than, you know, actually having taken a look at Host. That's my feeling.
So I haven't used Unity. So Horst is really a video player. So we're expecting some kind of 360-degree video, although you probably could easily adapt it. So if you're a programmer, you could probably adapt it easily to use different kind of formats, or I don't know, renderings, because like I said, it's using FreeJS and WebGL, and that's just, so that makes everything possible in the browser, I would say.
Okay, final question then. I need to be a bit more strict with time. Do you plan to expand the documentation for how to use and embed Host? People would be interested to use it for listening tests.
I think we would need some specific questions to expand the documentation, because like, so for me it is, I always get questions. We get contact emails and I get questions, and every time I answer a question which was kind of new, I try to integrate it into the README on GitHub. But yeah, so I try to answer all the questions there. If you have specific questions, just ask me, and then I'm happy to also add it to GitHub.
Yeah, within reason, I'll say, so that you're not, maintenance is its whole own thing. And no worries, look, any of the questions that are coming in, I think they're completely valid. We're just trying to put pieces together in everyone's heads when we're not in the same space and figure out what the question is and then how to answer it. So thank you guys. I'm sorry it's such a brief period of time, but I'm running over now, so I'm gonna end it. But stick around for the chat if you're able to, and then people can ask further questions and take your details or find you online. Okay, I'm going to move along. Thank you very much. Thanks,
Great,
guys.
thank you.
So next up we have Leslie, Christopher and Roddy. Leslie Gassenbird is a Dante certified audio engineer specializing in 5.1 re-recording, mixing and sound editing. She's a former governor at large for the Audio Engineering Society, author of the book Women in Audio. She's a member of the Recording Academy, a member of and council person of the Association of Motion Picture Sound, and a member of Motion Picture Sound Editors. She's worked for public radio in Washington and Colorado, the Colorado Symphony Orchestra, the Postmodern Company, and was a tenured associate professor at the University of Colorado, Denver. Christopher Willits is a pioneering electronic musician, producer, educator, and co-founder and director of Envelope, a nonprofit with a mission to unite people through immersive listening experiences. As one of the core artists on the Ghostly International label, Willits' immersive ambient music has reached millions of listeners, and includes collaborations with Ryuichi Sakamoto and Ticho. And I hope I've pronounced those correctly. I probably haven't, and I'm struggling to find Roddy's biog. Sorry, Roddy.
All good.
Do you want to fill in? Is that what you're suggesting?
I'm just one of the developers of Envelope and one of the co-founders.
I do have it. I've been cutting and pasting. So let me offer you the same privilege as other people.
Totally cool.
Roddy is an entrepreneur and software engineer, co-founder of Envelope board member, and co-founder of Hustle. Roddy performs live immersive electronic music as The Ride. Thank you, guys. So this part of the session is the second part of Ambisonics, which is the second part of this afternoon session. Chris and Roddy obviously work together, and Leslie is on board because really, in order for this not to be just a show and tell, Leslie's been brought in to try out some of the software and some of the tools in use and just act as if she were a member of the audience, but on the panel so that it can be more interactive. So I'll hand over to you guys and thank you.
Wonderful. Thanks so much, Angela. It's great to see you all today. Good morning from San Francisco. See some old friends in here. Yeah, really grateful for the space to share this with everyone. So yeah, hello, we are Envelope. I'm the co-founder along with Roddy. I'm also the executive director. And we're doing a lot of work with Envelope, and we're excited to share a specific project that's called Earshot. This is kind of like the new addition to our family here. First, we want to give a little bit of a primer on what Envelope is and what led us to Earshot. So we're a nonprofit organization. We were formed in 2016. And 2017, we opened our first venue named Envelope SF. And it really helped us understand where the impact socially, emotionally, creatively is with immersive audio. And so our whole focus as a nonprofit is to bring people together through immersive listening experiences. And we do that through our venue structures. We do that through open source software that we create, which now Earshot has become a part of. So we host a lot of different events. This is Envelope SF. We do live performances, listening events, a lot of educational workshops and wellness events. It's just been really incredible to host over 700 events in here since 2017. As I was mentioning, we also have an open source tool that's called Envelope for Live. This works with Ableton Live 10 Suite or 11 Suite. And it's really exciting to see so many producers and artists start to get into the world of Ambisonics. and create more emotionally impactful music. Anything you create within Envelop for Live can be used within multi-channel venues like Envelop SF or pop-up systems. It can also be used within VR and every other application of Ambisonics. Through the pandemic and the year before, we've had over 30,000 downloads of the software, and we're starting to see a lot of incredible ambisonic work that's being created with this. So that leads us into earshot. Through the pandemic, it really forced us to think differently about how we are sharing immersive experiences with our community. And we saw an opportunity to go a little bit deeper than the normal streaming models. And so we began Envelop Stream, which is serving spatial audio experiences. So using all of our tools, but with headphones. And Roddy has really taken it to the next step here with a team of developers, and yeah, really excited to go deeper here with Roddy now.
Hi everyone, and thanks Angela for the opportunity. So what is Earshot? Earshot is a transcoder for live streaming higher order ambisonics and other multi-channel content up to 255 channels. And we really started this project after March of last year, when COVID forced our venues to close and we actually had to shut down our venue in Salt Lake City. And so we started getting interested in, what would it take to take some of our immersive content and live stream it to our members and audiences over the web. And looking into it, and also inspired by Nils and Tommie's work in host, we thought that, we started exploring kind of what it would take. And what we found was that there were really no commercial transcoders that supported higher order ambisonics or any other non-standard channel ordering. You have, Amazon has a set of transcoders. You have some other things out there, but really 5.1 was kind of as far as it could go. And so there wasn't anything that gave us the flexibility we needed to do ambisonics. So we built Earshot. Basically, it's sort of an assembly of different projects. Mostly Nginx RTMP, which is an open source transcoder built on Nginx, Docker, FFmpeg, MPEG-Dash, and Opus, which Nils and Tommie talked about. And the goal is really to provide this infrastructure for people to deploy their own custom live streaming applications that use ambisonics or other multi-channel audio. And it's built to integrate with OBS Music Edition, which is a fork of OBS that's maintained to support live streaming up to 16 channels. And then it also integrates with the Envelop for Live software that Christopher mentioned. So anyone who's using Envelop for Live to produce third order Ableton Live sets, that can easily be live streamed using Earshot. And the goal is to make this low cost and simple to deploy. So we integrate, there's a set of templates for deployment to Amazon Web Services using the CloudFormation software. So you can, and AWS allows you to easily scale up. So if you need more, if you're doing, a lot of different adaptive bit rates, for instance, or high quality video, HD video, 4K, whatever, you can choose, the compute power that you need from Amazon, and you can deploy Earshot very easily. And it's all free and open source. So I know we have limited time, so I just thought I'd share a couple screenshots here. So this is OBS Music Edition, and you can see here it supports up to 16 channels. And anyone who's used OBS knows it's a very intuitive, really powerful software for live streaming. This is what we call web tools. So once you deploy Earshot, there's this web interface that lets you see all the different live streams that are being transcoded currently. You can see a bunch of information about the MPEG-Dash, different adaptations, representations. You can preview the different channels. So here, this is a 16-channel live stream. You can see latency, buffer level, a bunch of stuff. So really kind of helping people to not just deploy a transcoder, but also help with monitoring and debugging. And there's also, you can't see it here, but if you're using, if your application is using dash.js, you can tinker with different client settings for dash.js pretty easily and see kind of how it sounds. And then this is a thing that we're working on, a kind of next generation of envelop stream, but just a quick preview here. This is what it'll look like on the client browser. So you can take that, we're actually streaming those 16 channels of third order Ambisonics to a browser. And then on the client computer, they can choose to decode it to binaural, they can decode it to quad 5.1, or if they have a different decoder on their local computer, they can just pass through the full stream using software like Loopback and then decode it locally. So this really gives us the first ability to take 16 channels or higher order Ambisonics, take them from a source computer, live stream over the web with very high quality, and then have it be decoded onto whatever the client has. So this is coming soon. Stay tuned. But more on this, and we'll share with the group when this is available. So if anyone wants to check it out, it's at github.com/envelopsound/earshot. You can also see our other envelop tools out there, including Envelop for Live, or check us out at envelop.us. And with that, we can take any questions.
That's great. Thank you, Roddy. Thank you, Christopher. Some questions have come. They've been coming through. I'm keen to get some input from Leslie if that is appropriate. I don't know if it's not, and if not, we can skip through to the questions that have come through.
Well, just a couple of things that come to mind. Hey, it's nice to meet you guys. And I think it was completely accidental on Angela's part to put the Americans together. That was not intentional. But yeah, I'm kind of curious about a couple of things. And I'll keep mine short because I know some other people want to ask questions. But your head-related transfer functions, are you using a database in particular? And then my second question was re-rendering over multiple loudspeakers, whether you've tried to do that.
So the HRTFs actually aren't included with Earshot. So Earshot is really just a transcoder. So you can put 2 channels, you can put 16 channels, you can put 255 channels, you can put 4K video, you can put no video. It's really totally flexible and kind of what you want to put into it. So in this case for Envelop Stream, we've been testing some different HRTFs, including the Omnitone library, which seems to work well. But again, that's really up to the application developer. So Earshot's really not itself a consumer product. It's really for application developers who want to develop live streaming applications that use third order Ambisonics or higher order Ambisonics or anything else. I mean, you could put object-based, it's not limited to Ambisonics, but it does give you just the flexibility to kind of do whatever you want.
Cool. And then my other question just had to do with, have you ever, within your venue or any other, within Envelop SF or any other venue, have you tried transcoding and then decoding on the other end? And have you had some success with, with uniformity of purpose, for lack of a better term?
Mm-hmm. Yeah, that's something we definitely want to experiment more with for sure. That's been one of the dreams for a long time, is to have concurrent events that happen. Or perhaps we do an event in Envelop SF for another venue and it can stream at a later time for other time zones, things like this, just to make the experiences more accessible for everyone.
Thank you. And I'm sure, Angela, would you like to moderate the other Q&A?
Yeah, I'm going to go wild and let's go over time. It's funny, Roddy, that you say this is not a consumer product, because for me, as somebody that's somewhere between, a consumer and a technologist, I'm comfortable, but I'm not a developer myself. This is a very friendly interface. This is something that I feel is very amenable to my use. Yeah, questions coming in. We've got Nick Rawlins is asking a number of questions. Are there automating / modeling plugins with Envelope?
That's Envelop for Live. Yeah, I saw that question come in as well. Okay. So yeah, please check it out. You can find it at envelop.us and just click on that software link down there. And all of these work with Ableton Live Suite 10 or Ableton Live Suite 11. Very light load. You can do all kinds of spatial panning. We also have a number of effects in there, and the library of different tools keeps growing. It's really exciting to see the developer community start to, adapt and evolve these tools with us. So yeah, would love to hear your feedback on it.
Nick has also asked what the latency is with Earshot in a live setup for network performance.
So yeah, great question. So you can kind of choose your latency. If for our application that we're developing for Envelop Stream, what's important is the quality and the uniformity. Like, we don't want gaps and things like that. 30 seconds of latency is not a problem. There are other applications which may require more real time, and there's some settings you can tweak to have it to be more real time and low latency at the potential sacrifice of quality or having gaps in the stream. So it's really up to you. All of the FFmpeg, it's the transcoder behind the scenes is FFmpeg. So all the FFmpeg settings are available to you, and you can just have them as a parameter when you deploy as these additional flags that you can put in. And then also on the client side on Dash.js, you can tinker with different latency settings and see how those impact the stream. So it's really up to you. It's depending on the use case and how you want to use it.
I'm going to take one more question and then move on. And it's from Sean Guy, who's just asked, are you reopening the venue soon? It's just moved away from San Fran.
Oh, we are so excited to do everything we can to begin events again. So we're listening closely to all the health and safety guidance from San Francisco County, and it's looking like we can begin some low capacity events in the near future here. So yeah, please stay tuned, sign up to our newsletter, connect with us on social media. We'll be making some announcements pretty soon here. So yeah, thanks so much for asking.
Great, thank you guys. That was an amazing presentation and really informative again. And I hope that you'll stick around just for the Q&A and the chat. I think it's kind of blowing up, but we don't have time, unfortunately, with that. So I'm going to move along to our next set of people. But thank you again.
Thank you so much, Angela. Thanks, everyone.
Okay, so our final part of this afternoon session is we're kind of ramping up the technology and get prepared for the next session if you feel like you're a newbie. So the next session, part 3, is web audio API, web audio in the browser natively. And I'm pleased to introduce a number of people for this session. We've got, again, Leslie. So I won't read out your bio again, Leslie, if that's okay with you. How was I going to do the Q&A? Let me just go back to my plan. There was one. I know that Lorenzo has to run away. So I think maybe we'll go through the presentations and then we'll throw it open for questions, if that's okay. I know that people are doing things in quite different ways, particularly High Fidelity's solution is it sort of stands on its own a little bit, I'd say. But yeah, just in the interests of time and schedules, I think maybe we'll go straight through from Josh to Lorenzo, and we can always do Q&A in the chat and the Q&A panel. Okay, so Josh Reiss is a professor with the Centre for Digital Music at Queen Mary University of London. He's published more than 200 scientific papers and co-authored the book Intelligent Music Production and textbook Audio Effects, Theory, Implementation and Application. He is the president-elect and a fellow of the Audio Engineering Society. He co-founded the highly successful spin-out company, Lander, His second startup, Tones, has received investment, and he recently launched a third, Nemesindo. I hope I've pronounced those correctly. Over to you, Josh.
Okay, thanks a lot. Hopefully everyone can hear and see me okay. I'll take that as a yes. It's always weird hearing your own bio. It doesn't sound like me. I think I just need to cut it all out and just say I'm me. So I will go ahead and share my screen. And yeah, so I'll be talking, of course, about spatial audio in the browser, surprise, surprise, with a focus on the perspective of the startup that was mentioned at the end. It's called Nemesindo. Then we picked that name because it's the Zulu word for sound effects, but mainly because the .com version just wasn't taken. So first off, full disclosure, I really love the Web Audio API. Despite all its faults, and there are many, it can do almost everything audio that you want. And if it's not a built-in node, there's a way to extend the system to allow that to be done, as you've already seen with all of the Ambisonics work. But all the things that are not specifically focused on spatial audio still have parameters like channel count mode, channel interpretation, which allows it to render, to take as input and output huge numbers of channels and to treat that audio in different ways, including automatically upmixing or downmixing the audio as necessary as the signal passes from node to node. It also has channel mergers and channel splitters for dealing with large number of channels and manipulating each channel individually. A standard stereo panner, the audio worklet, which allows you to create your own worklets, your own nodes, and the panner node, which is the main spatialization tool. Quite similar to how panning is done in OpenAL, Microsoft 3D, and a few others. But essentially, there's a listener somewhere in the space. All of the sources that pass through panner nodes have their own orientation, a sound code that determines directivity, and their own location. And so then based on the distance, based on the panning model being used and the directivity of the sound code, it renders everything either with HRTFs or just using azimuth and elevation angles, and then down to a more standard equal power panning. So what does this all have to do with this Nemesindo project? Well, Nemesindo is a startup company based around procedural audio and sound effects. The basic idea is that sound designers, when they want sound effects, they work with sample libraries. They find a sound that's close to what they want. That's an uncreative way to work. No one enjoys just searching for sound effects, and it's not procedural, it's not adaptive. You can't, there's a limit to how much you can modify a sound once it's there. So what we're trying to do is offer procedural audio, generated sounds for all of the sound design needs. So I'll play a quite short video here that hopefully should get across what we're about, and then I'll tell you what we're doing that's specifically related to spatial audio. Apologies. Okay, so that gives a feel for what we're all about. The individual sounds that one might generate, they can typically be mono or stereo, but if you're going to use that sound in game or films, you want a full immersive experience. You might want a soundscape where all of the different individual sounds are placed all around you. So that's not the core of what we do, and I'd certainly love for it to be Ambisonics, but we do use that panel node that's part of the Web Audio API to do some 3D rendering. So I'll just pick any of our models here. And you see we generate applause sound here in the middle. I'll play a bit of that. But we can also, I'll leave it playing. You also have standard padding up the sound. And the spatialization feature over here, where one can specify where the sound is coming from around you. So specify a room, specify its location in the room, specify the source position in terms of back and front as well as width and height. And so that's all using the support parameters that one has access to with the Web Audio API. So that's what we're doing for spatial audio in the browser. I think in future we would like to be able to deliver ambisonic rendering. And I should also note that quite a lot of the models, they have some individual aspects of spatialization embedded into them. So like our propeller model allows the aircraft to go from left to right, but all models you can apply 3D spatialization just using the built-in panel node in the Web Audio API. So I think I've actually ended early enough to take a question or two now, if that makes sense. Don't know if that's okay.
I am aware that Lorenzo had to run away, so I'm just keen to maybe late.
I can stay until 5, so there probably is time.
Okay. So let's see any questions that have come up. We just had some issues with. I have a feeling that Zoom doesn't preserve quality in any kind of browser sharing. Because I've noticed, Josh, with your interface there, it was quite pixelated, and that was the same with Tommie. So I don't think we saw the fine details of that, and I don't think we got the full sort of impact of the sound. So I do encourage people to check out the Nimicindo in the browser. The links are all on the pages that you signed up via. So I would encourage you to get the full experience there. I think I will head over to Leslie with questions for you, Josh.
Okay, well, earlier, hi Josh, it's nice to see you. And earlier, I had been asking about rendering this in 5.1. So, I'm working with Sound for Film here in Brighton. And so, are there plans to integrate it with Pro Tools or anything? I know that this is a browser-based solution, but it's also a film-based solution. So what are your ideas on, being able to drop it into the exact time code and have it all synced up with pictures?
Yeah, I would love to. So we have an ongoing project to offer procedural audio for Unreal, game audio engine. And so we'll be porting the models from JavaScript Web Audio API to C++, which means we should be able to deliver them as VST plugins and that sort of thing. To properly integrate the browser solution with something like Pro Tools, it's just a real pain, and we don't have the resources for it I have talked to some film sound designers, and that's exactly what they would like. And we can streamline the process a little bit, but probably not offer really what they want unless we get it into a plugin form.
And then for users to create, I mean, to add to the library, you might have actually touched on this, but if, for example, I had to create a swarm sound effect with little nanobots, for example. So is the idea that you could upload, for example, the sound of an electric toothbrush, which is what I used for that design, and then be able to customize those parameters, or are you sourcing the sounds and then adding the parameters yourselves?
So all of the synthesis models are developed in-house, although many of them are based on things from the research community and published papers and so on, but it's internal development. We do have a few tools so that if you have a sound sample that you want to turn into a model, you upload that sound sample to say a sinusoidal model or granular synthesis, and it then generates a sound that you can manipulate. So what it's not is a development platform. It's geared at the sound designers, especially amateur sound designers, not at the people who already have some skill with audio programming. That would be very cool. It's just we're not doing it.
Right, even with film students who are learning sound. So, you know, coming from one skill to the other, that's pretty cool. Thank you.
Great, thank you. I'm going to jump in just in the interests of, we've got 10 minutes with Lorenzo. So, Lorenzo Picinali is a reader in audio design, and leads the audio experience design research theme with the Dyson School of Design Engineering at Imperial College London. In the past years, he's worked in Italy, France, and the UK on projects related with 3D binaural sound rendering, interactive applications for visually and hearing impaired individuals, audiology and hearing aids technology, audio and haptic interaction, and more generally, acoustical, virtual, and augmented reality. The research he's been involved with in the past years focused mainly on the implementation of a binaural spatialization tool, which also integrates a hearing loss simulation and virtual hearing aids, and on HRTF selection, evaluation, and adaptation. Okay, apologies that I'm going a million miles an hour with that, but yeah, trying to keep us on time. And I'll hand over to you. Thank you, Lorenzo.
Thank you very much, Angela. And thank you for pronouncing my name with a very Italian accent. That's great. Cool. I'll try to share my screen as well. Can you see? Can you all see? Does it work?
Yes.
Brilliant. So I'm here to present a tool that we call PlugSonic, and it's a suite of web and mobile-based tools for doing binaural audio. Now, I'm assuming that we are all familiar with what binaural audio is, and for the ones who are not, binaural audio, binaural spatialization is a technique that allows you to simulate immersive soundscapes. So sound coming not only from the left and from the right, but also from front, back, up, down, different distances, and etc., all using a simple pair of headphones. So let's take it like that. That's a decent, simple definition. That's what the technique does. So this tool is called PlugSonic. Just a little bit of background, because the development was funded by a project called Pluggy, which aimed at facilitating the creation of 3D immersive sonic narratives for digital heritage. Now, this tool has nothing to do with digital heritage per se, so we'll skip that aspect and we'll focus on the tool itself. Now, it's a suite because it's composed by different elements. Now, the PlugSonic family, first you have an application that is called PlugSonic Sample. Is a very simple web editor using the Web Audio API. I'll show it to you. It's an audio editor that allows you to do a few simple things on audio samples. The reason for the inclusion of this tool is because really we wanted to allow naive users, so users with not particular experience in audio, to be able to take whatever recordings they have, edit them, put them together, create an interactive soundscape and navigate it. So the sample takes care of the individual audio stems, let's say. Then you import it into the Soundscape app, and you have a Create Soundscape and Experience Soundscape, and both are web-based. And you also have an Experience Mobile. So the Create Web is an app where you import audio samples, audio or mono audio files, and you put them together into an interactive soundscape. So you basically define a room, define its size, you can input an image, and then you can position them in different positions, in different places. Now, if you can see my browser, I believe you can, this is the link where you can find the Plugsonic sample. There is a small disclaimer. And here is how it works. So what I can do is I can import an MP3 file. I have a few prepared on my desktop here. I'll drag and drop it here. This is a base. So I'll just write it and I add the source. The source appears here. So now I can position this source wherever I want, and I can control, for example, an interaction area. For example, I want the source to play when I enter the area, or maybe to just increase its volume when I enter the area. You can then obviously add multiple sources and other elements of the soundscape. Like here, I could add another source, and these are the drums. Here, add source, and I see them here. So I can compose my soundscape, and then with the use of the arrows, or maybe even my mouse, I can travel around. And I can actually hear the binaural rendering of this. I can turn my head around, I can press play and stop, and control several parts of the interactions, including, for example, some rather advanced features, because the spatialization is done using our tool, which is the 3D tuning toolkit, which allows you to, for example, choose an HRTF that maybe best fits yours, or potentially you could also import your own, not in this particular version. You could customize the rendering to your head circumference, and you could make a lot of other choices related with rendering. Now, once you are happy with whatever you have created, you can then move to saving this soundscape. And you can save it and export it as a sort of as a JSON format that we have created that can contain only metadata, for example, information about where the sources are, and then you'll need to import the audio files, or also metadata plus assets. So you will download a big JSON file that contains also the audio channels. Now, in this case, this is useful because then, if you go back to our PowerPoint, you can then export this re-import this JSON file into our Experience web application, which is basically the same as the Create, but you simply load a file, reload the soundscape, and experience it and navigate it. But we also have an Experience mobile app. Now, this is an iOS app that you can download, and you can actually import on that app the same JSON file. It would load the experience. It would use the accelerometer on the device to navigate, to rotate within the soundscape. And actually, we have now integrated also with the Apple AR kit. So it would also, after having mapped the environment, allow you to physically move within the environment and to interact with the various sound sources as you have decided and when you created this soundscape. So the suite, again, a Create web, which is the interface I showed you, where you create this interactive soundscape, importing mono files and deciding what kind of interaction you want to have. Then the Experience web, where you can then import this JSON file with all the assets and the metadata, or the Experience mobile, where you again import this JSON file, but in that case, you can actually physically interact by rotating and actually moving inside the environment. Now, I will definitely share with you this link, this page, because it's got all the needed links in order to find these, and these all open source. So we have GitHub accounts and GitHub repos for each of the codes that you can find. The mobile is not on the Apple Store, but again, you can download it and compile it by yourself. And here is a pointer to the platform of this Pluggy project, which is also related to this software, but is not needed. I just wanted to say something very quickly about our audio engine, which is the one we developed here. Again, open source, is in C++, but we do actually have a JavaScript wrapper that will allow you to integrate it into web applications. We have an example, which is our online toolkit, and the Plugsonic suite is an example itself. And then there are a couple of videos on YouTube which you can watch and listen with headphones about demonstrating the functionalities of the toolkit. This is an important slide. Obviously, there is the development team. Marco Comunità, he's the main person who programmed the Plugsonic. Andrea took care of the sample and the iOS version, and Vera helped with the user design and with the evaluation. And here are a couple of publications. Now, I don't know how much time I have, but I have here some of the questions that Angela asked that I thought would be interesting to answer in general. But if there are specific questions from the audience, I'll be happy to answer also to those. You tell me what you prefer me to do.
I don't think any questions have come through, but I wanted to check in with Leslie again, just to find out if there's something that you had from your experience with it.
No, you know what? What I'd like to see is the Q&A that we've come up with, that Lorenzo's come up with, and then I'll jump in after that. How about that?
Brilliant, excellent. So the first one, what issues does your product overcome in terms of spatial audio through the browser? Well, we designed this because we wanted to create an easy-to-use set of tools that allowed everyone to start with some standard mono recordings and come out with an interactive soundscape. Now, to my knowledge, there is nothing that allows to do this in such a simple way, using web browsers and without using specialistic digital audio workstation software. So this is, I think, the problem that it solves. In addition, there are some tools that do some binaural audio on the web, and Josh showed a few of them, but at the same time, the toolkit, the 3D tuning toolkit, was developed as a research tool. So it was developed to offer some sort of very advanced 3D audio, binaural audio, doing some advanced sort of interpolation between HRTFs, doing some near field emulation, so you can really actually simulate very close sound sources, doing some binaural reverberation, which is something that generally is not done appropriately, allowing you to select HRTFs, to customize the rendering to your head circumference. So all these, I'm not aware of a tool that does it all, most of all on a web-based interface. So this is also what sets this apart from alternatives. I'm not aware of an alternative that does all this. And also I would add that is also open source, and it is available with the GPL version 3 license, so everybody can use it for free for, use cases, well, this was developed in a project on immersive audio narrative for cultural heritage. But we use it in many areas. For example, we are recently using it in a project called BEARS, where we are looking at training bilateral cochlear implant users to learn how to use both ears to localize sound sources and understand speech in noise. So we're using these immersive environments to create a set of perceptual training procedures so that they can relearn how to use both ears together and perform better in real life speech in noise situations. So this is one use case. We have had musicians using it to create some not only immersive sound compositions, but also interactive, because as you know, as you have seen, you can interact with the sources and not only change the level and their position, but you can also change when they play back. You can create a path and something to be explored interactively. Skills, it depends. If you want to use the JavaScript wrapper and go into the code and adapt it to your need, then you will need to use JavaScript. But if you don't have that knowledge, you just need to be able to use a browser, and that's all you need. Obviously, for the mobile version, at the moment, there is not available a compiled version, so you'll need to be able to download the repo and compile it with Xcode, but that's relatively straightforward. Steep in the learning curve is very simple. To use the software per se is something that you would learn in very rapidly. Just read maybe some parts of our paper about the software. We will actually publish soon, hopefully it gets accepted, a paper on the technical challenges of the software, but it is simple. What artist or practitioner applications does it have? I think I've already explained some possibly use cases, and I'm sure that whoever uses it will come up also with other ways of using it and creatively.
Fantastic, thank you. And what great questions those are, Lorenzo. There are a couple more questions in the chat, but in the interest,
I can answer if you want. I have moved my meeting 10 minutes.
I feel like I don't want to hold our final speaker up. We're already 10 minutes behind. Okay. If you're able to answer them in the chat, everybody can still see them, and that means we'll slightly stay on time if that's okay. But thank you.
Absolutely.
I feel there's a lot more we could ask you on this, so it's a shame you can't stick around, but everybody now knows who you are, what you do, and hopefully they feel comfortable to get in touch with you if that's appropriate. Yeah, I'm imagining only people that would have something specific to ask would do that, and you won't be inundated.
Perfect. Thank you.
Thank you so much. Thanks, Lorenzo. Okay, our final speaker for today is Philip Rosedale, co-founder and CEO of High Fidelity. The company's API allows developers to integrate its patented real-time spatial audio, originally developed for immersive VR experiences, into their apps, games, and websites. In 1995, Rosedale created Freeview, one of the first internet video conferencing apps, which was acquired by Real Networks. He founded Linden Lab in 1999, the creators of Second Life, which has become a home for millions of people and has a multi-billion-dollar virtual economy. Philip holds a BS in physics from University of California, San Diego. So without further ado, I will pass you over to Philip. Thank you for joining us all the way again from the West Coast, like Roddy and Christopher.
Thank you so much for having me. I always know I'm in the right room when I connect and I see all the headphones and the big condenser mics. It always makes me happy. Thank you very much for having me. I'll give you a quick overview of what we're doing. A lot of this stuff is available at our website today because it's up and running as an API, highfidelity.com/API. I'll come back to that at the end. But maybe what I could start with as introduction is just the genesis of our work, which has been a specific use case that we've been trying to solve for. In about 2013, High Fidelity was started, and our initial mission was to create a new kind of virtual reality platform where a lot of people could be in the same space at the same time talking to each other while wearing head-mounted displays. So that was the basic problem that we took on as engineers at the outset. And so we've been working for the past 7 years on other things as well with regard to virtual reality. But the core of our work has been this challenge of how to create an audio experience for 100 people walking around together in a room as avatars, all wearing head-mounted displays where they're continuously adjusting their head pose. And our goal was to give them an experience which was as close to reality as possible. So this presented a couple of key engineering requirements that I think made us take a little bit of a different direction, which is what some here may find at least interesting in terms of what we had to do. The first requirement was low delay. Because this was to be a live because High Fidelity is, a live communication system, we wanted to get the mouth to ear latency of the system for all participants down to below the 180 milliseconds or so, which is, the kind of knee in the curve, at least from the, ITU studies that have been done, where if your mouth to ear latency is less than 180, you've got good salience during conversation. You don't feel like you're stepping on each other. And obviously, as we've all known from our phones, in recent years, if it's a lot higher than that, it's a terrible experience. So we had to get a very low delay to the end user. And also we wanted everything to work in the browser. This kind of ruled out ideas like web audio, for example, where there's a substantial delay, 100 milliseconds or more, that is added by invoking that stack. And instead, what we decided to do was for the API that's available today was use WebRTC directly and presume that we weren't going to touch the audio at all on the receiving end. We were going to send 2 channels of high quality stereo to each participant using WebRTC to be able to get that delay down to say what it is in this Zoom call, or likely is for many of us. So we had to take a very different design direction there with bringing the audio down as a WebRTC stream. What we did was to accommodate that, obviously, was we had to create a mixer in the cloud, a server that is doing the job of mixing together all of the sources in real time and then presenting a single stereo stream down to each receiver. So in distinction from many of the other solutions that are around, we are doing everything on the server and then sending you the final mix as a real-time participant in your space. So the way that we took that on was to take an existing HRTF model and then try to make it fast enough and have a small enough, framing window to be at the cloud there and not add any latency and have the same performance of the sort of typical forwarding strategy that's done for multi-stream WebRTC. In fact, this, again, this Zoom webinar is a multi-stream thing where we've got as many potential incoming sources as there are people simultaneously speaking. So if we all yelled at the same time here, it'd be problematic. So instead, what we wanted to do is do all that mixing on the server. So we took on that problem. That's what we've been working on and iterating on. And what we've gotten to, and there is a demo of this, a live demo. I'll say it here, and then you could perhaps go to it again. It speaks a lot more, I think, eloquently than anything I'm going to tell you about what we're doing. It's highfidelity.com/ZARU, Zaru, which is our little private live kind of theater space where there are a whole bunch of made up people and a singer and some music and stuff. And you can drive around on your browser in that space and get the feeling of it. I'll repeat this at the end, but that's probably the most interesting demo when you have time that will give you an idea what we're doing. So on the server, we are continuously performing an HRTF for each source, for each receiver. We're not using Ambisonics. We chose, because of course we were going to be avatars walking around in a scene, to take on this challenge of doing a full binaural HRTF for each of the sources. So that's what we're doing. We can support on a big cloud machine, like a big Amazon machine, hundreds of source receiver sets at the same time in the same space. And then we also have a technology that we've not yet made available in the API, but that is available to partners that we're working with, which uses a kind of a peer network of mixers or servers to mix down all the sounds associated with a single server into a single spatialized source, which is then sent to the other servers. So in this manner, we've been able to get up to numbers like about, I think the most we've done is 5,000 people in one single space, all within earshot of each other, using this same technique of again, doing the HRTF on each of the listeners. And you know, the hard parts of that, we're doing a very fast approximation of a very good HRTF. Again, listen to it and see what you think. And then the other trick was peak limiting. When a lot of people are talking at the same time, you obviously have a collision and overrun problem that you have to solve. It turned out that actually is a pretty sophisticated R&D problem to do well, and again with a low frame delay and high quality. We've also done a lot of good work on things like noise gating, although I would say some of the great AI-driven work that's happening in the field now on that is amazing. So that's basically us. That's what we do. Again, thank you very much. I think, Angela, for putting that in the chat. highfidelity.com/Zaru is this demo. It doesn't require anything special. It works on your browser. We've also worked to make this all work on the phone. Again, that was part of the design constraint, that we had to do all the mixing in the cloud, obviously, because we wanted to send, just one stereo signal down to a person on a mobile device. And the API today is up and running. You can use it to integrate into things. We've had a number of companies integrate it within a couple of hours of work. So it's a very simple model where you tell us what space you're in, what your orientation and position is, and then we send you back the stereo feed. So there's nothing in the way of individual connection management or the processing of discrete streams. Yeah, with that, let me wrap up and just say, if you get a chance to look at the demo, try it. And I'm excited to take the questions, and I'm very delighted to be here. I've had so much fun listening to the other presentations. And I would say that audio is obviously a very early and exciting space that's not done yet, especially as it relates to live communication. Thanks, everybody.
Thank you. That was great. I would say, I mean, what strikes me as you present there, Philip, is the attention to detail really given to kind of, what are, as human beings, what makes for a good listening experience. And certainly that's what came across to me when Ashley took me through the demo. I probably like many people in this webinar, I'm very sound sensitive, and so I get very acoustically stressed very easily, and video conferencing is such a pain. It stresses me out for all kinds of reasons. But I think when I went into that demo environment, one of the things I realized is it doesn't have to be like this. Actually, we can have multiple sound sources and it feels peaceful. I have the feeling of, not having this acoustic stress coming at me, which I think is a bigger stress than the image, for me at least. And I wonder if it's not a bigger stress for a lot of people than they realize, because even people that are not like designated audio people get really stressed with the kind of, the kind of latency and just, the cross communication. So it comes across very clearly to me now, the level of attention to detail you've given this. So it sort of makes sense.
I would add, I agree. Thank you for kind of pointing that out. That the simple thing that I know we're all aware of here is simply that, yeah, multiple speakers at the same time in a video conference are inaudible because of the combination of ducking that some of the applications do, and then the more important issue, which is that two voice sources coming from the same point in space for you become indecipherable, for most of us almost immediately. And separating the sources using a binaural HRTF causes them to become understandable. And just like you say, the feeling of relaxation that you get out of that is wonderful. We as a company, all of our meetings, as you can imagine, are in high fidelity. We don't use video. We all know each other. We don't need the video. And we use this spatialized audio. And it is one of the perks, of all of us working together, is that we're sitting enjoying this warm, high quality spatialized sound.
And I would just further to that add that for video conferencing software that isn't set up spatially, we'd kind of go, oh well, that's because it's it's not designed for the kind of use that maybe it's now being commonly employed for. But actually, if you go into an environment like Mozilla Hubs, that's also quite stressful. Once you get a certain and a fairly low number of people in that environment, it becomes acoustically very stressful, and that's a spatialized 3D environment. So yeah, I think what you're doing is an area that adds something very valuable to the experience that a lot of us have. Leslie, do you want to jump in? I know you've also been through the demo.
Yeah, I just wanted to ask a quick question because we're almost out of time, but what's your preferred headphones? Sealed back, open back, or earbuds?
Right now, and most recently when I've been doing a lot of, demonstrations and stuff, I use the Shure inner monitors and then a Shure microphone here. I've got another one upstairs. So that's been my go-to approach. I think for comfort, for people that are wearing, obviously, large over-ear headphones are the ones that we use, like I see in the audience here for a number of people. That's definitely my preference. I love you asking that because I always, like, when I'm doing demos and I can't see people, one of my almost like the how do you do in high fidelity is, Leslie, what are you wearing? What do you have on? We just will ask everybody that. It's great.
Thank you.
Great. I mean, I'm going to open it up, and I'm going to open it up more generally for the session on web audio. If anyone has a question for Josh. Unfortunately, Lorenzo has had to shoot off, but if anyone has a question or they want to share something, then now is the time. I will also say again, Philip, we've had a comment in the chat about the use of high fidelity for within an educational environment, and that's the second person I know that's using it educationally. Yeah,
it's right. We definitely felt both actually in our full VR version and now the audio work that we're doing that education was one of the cases where, as you touched on before, that there's a shift in the use model to be a need for natural standing in a circle talking water cooler type conversations, and that's the problem that I think we all as an industry have to now innovate on, and that's what we're trying to solve. Many level playing field speakers continuously. I saw somebody asked about Reverb Live. We do have a reverb model that we built as our I agree that reverb and being able to control the reverb of the environment is important. It's psychologically important because it creates a sense of shared presence. You more believe that you're in the same space with a person. And of course, as we become more close mic'd, the opportunity to add some reverb from a dry default seems like very compelling. We have a reverb model that we've built. We haven't deployed it again in our API, but we look forward to doing that. And I agree that it's a good idea. The way we've done it from a computational intensity perspective is, of course, not to try to do reverb in the server. I don't think that's feasible yet. That's too much compute, and it would be at too much cost even for the customer. But we do have a model to kind of add a programmable reverb at the end, but we need to get to a native client to do that, because again, in web audio, you can't touch the audio stream without creating too much latency.
great, thank you. Very informative. Okay, I'm opening it up more generally if anyone has a question. I think we've had a lot of information in the past couple of hours. I know I have. But I'm curious whether the panelists have any questions for each other at this point, because I'm sure there's a lot of interesting expertise in the room. Nope. Everybody's being shy. Okay. Well, I guess we'll wrap it up then. I will just read out something from the chat. Is from Ashley has said that High Fidelity is hiring engineers. So if you're interested, email hr@highfidelity.com. Yeah, I think I've basically covered all of the questions. Yeah. Great to hear diverse presentations. There's still much to discover and reconsider. Yep, absolutely there is. And I think from the kind of non-comprehensive, as I've said, survey of what's out there, and this is kind of where, you know, where I've gotten to with it, it's evident that things have developed for different use cases, and you know, just different kinds of interests are actually very evident at this point, and possibly that tells me that we're still at an early stage of evolution, which is very exciting. I think that it's also equal parts exciting and frustrating when you have to figure out, you know, how to integrate things and how to get your workflows working sensibly. But yeah, I just really want to thank all of the panelists for this afternoon session, and particularly those that had to get up very early in the morning, brought it all together, and everybody stuck to time. And I really value all of your contributions, super interesting. So thank you very much, everybody. And thanks for everyone that came along. Yeah, I will try and make this recording available in some way. I don't know what that means yet. So please, no promises from me, but I will try. And yeah, thank you everyone again. Hope to see you at the next Soundstack. Stay in touch and stay in touch with each other. Thank you.